Alright, hi guys. In this video I'm going to be covering chapter 2, grid questions 18 to 22. We're given a function f of x where the first part has two unknowns, a and b, that we're going to need to find. This function is differentiable at x equals to minus 1. What is the value of f of minus 2? Since minus 2 is less than minus 1, we're going to need to use this part of the equation, which means that we're going to need to find a and b. A and b are constants, and two unknowns means that we need to get two equations. This function is differentiable at x equals to minus 1, which means that it is continuous at x equals to minus 1. So the left side limit is equal to the right side limit at that point, x equals to minus 1. Simply substitute x as minus 1 in these two equations and equate them for the first equation. A times minus 1 cubed plus b times minus 1 plus 11 is equal to minus 2 times minus 1 plus 1. So minus a minus b plus 11 is equal to 3. A plus b is equal to 8. That is our first equation. We're going to put it up here. For the second equation, as we said, this function is differentiable at this point, x equals to minus 1, which means that the left side derivative is equal to the right side derivative. You could use the way with like the limits and stuff, but that's really long and complicated. So simply derive these two and then substitute minus 1 for x and equate them. So if you derive the first equation, you get 3ax squared plus b. Deriving the second equation, you get minus 2. Substituting x as minus 1, you get 3a plus b is equal to minus 2. So that's the second equation. So there are two ways to solve this. For me, I prefer the substitution way. So simply, we're just going to modify the first equation as such. B is equal to 8 minus a. And then we can substitute that into the second equation, which gives us 3a plus 8 minus a is equal to minus 2. 2a is equal to minus 10. A is equal to minus 5. And then we can substitute this back into the first equation. So, minus 5 plus b is equal to 8, which means that b is going to be equal to 13. B is equal to 13, a is equal to minus 5. We can substitute these two into this first part of the function. So the first part of the function ends up being minus 5x cubed plus 13x plus 11. And to find f of minus 2, simply substitute minus 2 for x. So minus 5 times minus 2 cubed plus 13 times minus 2 plus 11, which is equal to 25. So the answer here is 25. Moving on to number 19, we're given a function f of x and we are given a bunch of statements. We have to know whether they are true or false. So we'll start with statement number 1, which says that f of x is not differentiable at x equals to 0 because f of 0 does not exist, which is not true because as we can see here in the given, the function is defined for x equals to 0 and f of 0 is equal to 1. So number 1 is wrong. Number 2, f of x is not continuous but is differentiable at x equals to 0. This is impossible because for a function to be differentiable at a point, it first has to be continuous at that point. So number 2 is also wrong. Now number 3, f of x is not differentiable at x equals to 0 because it is not continuous at that point. We have to actually check this. So check the left side limit and the right side limit. The quick way to do this is just substitute 0 in these two equations and check if the value is the same and if it's equal to f of 0. So 4 times 0 plus 1, which is just simply 1, and 3 times 0 squared, which is 0. This is the left side limit, this is the right side limit. They are not equal and they are not equal to f of 0, which means that it is not continuous at this point and therefore not differentiable, meaning that 3 is correct. Statement number 4 says that f of x is differentiable, so it's wrong. And statement number 5 says that f of x is not differentiable, which is correct. Statement number 6 says that f of x is differentiable at the point, which is wrong. So the correct answer here is 3, 5. Moving on to question number 20. Again, we are given a function f of x and we are given a bunch of statements. So first of all, statement number 1 that says f of 0 exists, this is true. F of 0 is equal to 2 times 0 plus 1, which is just equal to 1. Statement number 2 says that limit of as x approaches 0 of f of x does not exist. We have to check the continuity of f of x at the point x equals to 0. So again, substitute 0 into these two equations. So the left side limit will be 2 times 0 plus 1, which is 1. And the right side limit will be minus 0 squared plus 1, which is also equal to 1. Both of these are equal, and they're equal to f of 0, which means that the limit does exist, which means that number 2 is wrong. And number 3 says that it is not differentiable at the point. You can do the method with like the limits and stuff, but that's really long and complicated, as I said. So simply derive these two equations, substitute 0, and see if they're equal. So you have 2 and you have minus 2x. If you substitute 0 as x into this, you just get 2. If you substitute 0 as x into this, you get 0. They're not equal to each other, which means that number 3 is correct. Number 4, as we already said, f of x is continuous at x equals to 0. Number 5 is incorrect because, as we said already, it's not differentiable at x equals to 0. Again, if this kind of question comes written, you have to use the method with limit, but if it comes multiple, there's just an easy way to solve it. Moving on to question number 21, we are given y is equal to minus 3x cotan x. We want to find the value of dy over dx when x is equal to pi by 4. Simply, we just want to find the derivative, and this y is in the form u times v. We're going to need to use product rule. So u is minus 3x, and u prime is minus 3. V is cotan x, and v prime is minus cosecant squared x. So y prime is equal to u prime v plus v prime u equal to minus 3 cotan x plus v prime minus cosecant squared x times minus 3x. So in other words, it is equal to 3x cosecant squared x minus 3 cotan x. We want to find the value of y prime when x is equal to pi by 4, so substitute into your calculators. Make sure that when you're doing calculations like this with cosine, sine, whatever, and you're using pi, make sure that your calculator is in radians. Okay, so after substituting into the calculator, we get 1.712, but we want our answer rounded to the nearest whole number, so we're simply going to round to 2, and that is the answer for number 21. Moving on to grid question 22, we are given that y is equal to 3 cotan pi minus 6x, and we want to find the value of dy over dx when x is equal to pi over 24. So we want to find y prime and then substitute pi over 24 for x. Y is, in this case, in the form cotan u, and we will take pi minus 6x as u, and so u prime is minus 6. So here the rule says that y prime is equal to minus u prime times cosecant squared u, which is equal to minus 6 cosecant squared pi minus 6x. So we'll substitute pi over 24 into this equation. So it's simply going to be equal to 6 over sine squared. Pi minus 6 times pi over 24 is just pi over 4, which is equal to 6 over sine squared 3 pi by 4, which is equal to 36. So the answer for this question is 36. Again, make sure if you have pi inside any trigonometric function that your calculator is in radians. Thank you.